All right, so solving this with work and energy. The way the problem's presented, it's a work and energy question because it says here, determine the change in kinetic energy of the block. Kinetic energy was not in Chapter 4. This is purely Chapter 5. Although what you could do, guys, because look, they're focusing on Block A. They want to know the change of kinetic energy of Block A. Well, what's change of kinetic? It's final minus initial. What's the initial kinetic energy of Block A? It says right here, everything starts from rest. So what's the initial kinetic energy? 0. So really, what we're looking for is we're looking for the kinetic energy of Block A final. That's pretty much what we want. So what's the equation for kinetic energy? Kinetic energy is 1/2 mv squared. So do we have the mass of Block A? Yeah. So long story short, what do we need to find? The velocity. Now look, some of you may have tried this approach. Some of you may have tried going, okay, change of kinetic energy. We talked a lot about this. What is change of kinetic energy equal to? Work net. But this is going to run into a problem because look, as Block A goes from here to here, there are 3 forces doing work. There's 3 forces doing work. We can get 2 of them. 2 of them are no problem. What are the 3 forces doing work as Block A goes up the hill? Tension does work. What else does work? Friction. And what else does work? Gravity. Those are the 3. The 2 that you can figure out are those. Now, to find the work done by tension, you have to figure out what tension is equal to, right? You got to figure it out. So that you could do that Chapter 4 style, sum the forces, do free body diagram, sum forces, figure out what the tension is in the cable, and then once you know what the tension is, you can find the work done. So here's what I did. Let me show you how I solved this. Okay, so we have 2 objects here, right? We have object A and object B. So what I said is I went, okay, the mechanical energy, in fact, can I erase, I'm going to need room here, dudes. Everybody got the problem? So I'm going to erase this. So here's what I said. Well, they told us this distance here is 20 meters, and then they also gave us the coefficient of friction as 0.25. Okay, mechanical energy of object A initial plus mechanical energy of object B initial plus or minus work non-conservative is going to equal mechanical energy of object A final plus mechanical energy of object B final. It's exactly what we've been doing, only we have 2 objects here, right? There's 2 objects instead of 1. Okay? Do we have any non-conservative forces? Yeah. What are the non-conservative forces? Friction and tension. But look, tension is not going to matter here, and look, here's why. Which way is tension doing work on object A? Is tension doing work in the direction of motion or against the motion? In the direction. Now look over here. Object B is, so tension points up here. Is tension doing work in the direction of motion or against? Against. So the work done by tension is going to cancel itself out. So we don't even have to factor it in. Does that make sense? We don't even have to factor in the work done by tension. Okay, so what's the only non-conservative force we have to factor in? Friction. So the work non-conservative, let's just call it what it is. This is going to be work of friction, and it's going to be minus. Okay, so we got to expand this out. And look, any springs in this problem? No springs. I'm not even going to put springs down. So mechanical A initial, this is going to be kinetic of A initial plus potential of A initial. So that's mechanical A initial. Okay, plus mechanical of B. That's going to be kinetic of B initial plus potential of B initial. Then minus work of friction equals, okay, this is going to be kinetic A final plus potential A final. And then for B, it's going to be kinetic B final plus potential B final. Now, we got to set our 0 points. Let's put our 0 points in. There's two different 0 points. Why are there two different 0 points? Because we got two objects. Where's the best place to put your 0 point? At the lowest point. So here is the lowest point for object A. So that's the 0 point for object A. Okay, what's going to be the 0 point for object B? Oops. Oops. What did I just do? Oops. Okay, there we go. Let me expand this out. Come on. Why did this shrink? There we go. So look, what's going to happen to object B? Object B is going to drop how far? 20 meters. Right? How do I know that object B drops 20 meters? Because how far does object A move? 20 meters up the incline, so object B drops 20 meters. The 0 point for object B is going to be here, 20 meters down. Okay, so that is where H equals 0 for each object, right? H equals 0, H equals 0. This is definitely a more complicated problem. Would you agree? All right, so let's go through the energies now. Do we start with kinetic for object A? No, why not? Everything starts from rest. Does object A start with potential energy here? No, why not? On the 0 point. Object A starts on the 0 point. Okay? So no potential A. All right. Object B. Does object B start with kinetic? No, it goes to 0. Does object B start with potential? Yeah, it's above the 0 point. Okay, then we got our work of friction. All right. Do we end with kinetic for object A? Yeah. When object A gets up here, it's moving, right? It's got velocity. Okay. Do we end with potential for object A? Yeah. In fact, what are we going to have to figure out here? The H. You're going to have to solve for that height right there. Okay. Kinetic B. Does object B end with kinetic? Yeah, it's moving. Does it end with potential, object B? No, because where does object B end? On the 0 point, right? So what we're left with is this. Potential of B initial minus the work of friction equals kinetic A final plus kinetic B final. I just put these guys together. And then plus potential of A final. Now look, I'm almost out of time here. This height right here, you got to solve for this vertical height. It's just trig, right? What's the incline there? 20. It's a 37-degree angle, so you use trig, and your H comes out as 12.04 meters. That's the H. I'm going to call that HA, and then this 20 meters over here is HB. All right, so now we plug in the equations. What's the equation for potential? But be careful here. Mass of B, gravity HB, right? Minus work of friction. What's the equation for that? Friction times displacement, right? Work is force times displacement, and they're parallel. Friction is parallel to the displacement. And then this is going to be 1/2 mass of A V final squared plus 1/2 mass of B V final squared plus this is going to be mass of A gravity HA, right? Hey, notice I did not specify for the velocities. Do you have to specify A or B? No. So look, you got to find friction. You got to find friction, and once you have friction, you can solve for V final. V final comes out as 12.5, right? And then once you have V final, once you got V final, what can you find? The kinetic. So the kinetic of A final, it comes out as 3,900 joules.